So we're talking about rational numbers and multiplying. Guys, we're going to talk about two different rules. Don't mix up the adding and the multiplying. They're not the same, okay? I think the multiplying rules are a little bit easier, and you should know them, but I'm going to review them just in case. So two rules. The first rule, I'm going to write it down, is if two factors. Okay, what do I mean by factors? What's that word factors mean? Someone just call it out. Yes, Sam?
Numbers that can be multiplied to make another number.
Yeah, it's just a number that's being multiplied. That's a factor. So if two factors, or if two numbers are being multiplied, and they have like signs. What do I mean by like signs? Yes, Marshall?
They're both either negative or positive.
Okay, they're both either negative or they're both positive. Good. If they have like signs, the product, what's product talking about? It's product referring to, yes, Carly?
It's referring to the answer for multiplication.
So if two numbers are being multiplied, two positives or two negatives, then their product, their answer is going to be, anyone know? An answer, yep, that's correct. Aiden? Okay, not necessarily even. It could be even or odd, but here's the key word. Positive. Positive. And I guess maybe that's what you meant by even, but yeah, positive, right? If two factors have like signs, the product is going to be positive. And here's how I can illustrate it with just the symbols. If I had a positive number times a positive number, so you see what I'm trying to say there? A positive number times a positive number, what kind of product am I going to get? Positive, right? That's easy. 4 times 3, positive 4 times positive 3 is positive 12. Easy, right? But what if I had, for example, a negative times a negative? What kind of product would I get? It would still be a positive. It would still be a positive because the two factors have like signs. That's the rule for multiplying. Do you notice I didn't put any numbers? Did I put any numbers in here? Because it doesn't matter what the numbers are, so I'm not looking at absolute value, I'm not looking at which one's higher or lesser, I'm just looking at the signs. Okay, that's the first rule. Second rule is like unto the first. Don't you like it when they're like just simple, straightforward rules, like 1 or 2? We're going to get to a lesson next week that has technically, you could say, 8 rules. But then we try to summarize it into 4, right? We try to make it easier because too many rules makes it hard to remember what you're even doing. So if two factors, we know what factors are, numbers that are being multiplied, have, what do you think I'm going to write next? Unlike signs. Unlike signs. What's an example of two numbers that have unlike signs? What does that mean? Unlike signs. Okay, yeah, CT?
If one of them is negative, one of them is positive.
One of them's negative, one of them's positive. Or one of them's positive, one of them's negative. Okay. There's got to be an easier way to do that, by the way. Okay. If two factors have unlike signs, the product is, what do you think? Is negative. Yes, negative. So we'll underline that. Two factors have unlike signs, negative. We can help you out to distinguish. So I'm going to put it like this. A negative times a positive is going to give me what kind of number? Negative. Remember, what operation are we talking about? Multiplying. Are we talking about adding and subtracting right now? No. Are the rules the same? No. So please keep it distinguished. What if I have a positive, though, times a negative? It's still negative. So please remember that. That's the rule for multiplying. What do you think we're going to talk about Monday? Sorry, not tomorrow. You can come tomorrow, but I might not be here. What are we going to talk about Monday? Day, what do you think?
Dividing.
Did you look at the next lesson? What? So you just figured that we're going to go dividing, and we will. Which is going to be a review of today's lesson. What? Time out. Pause. Swivl fans and YouTubers. Don't forget to like.
Epic gamers.
Which I sent your parents the email. I said, you can subscribe, And don't forget to like. Smile. So please, I really mean it. I need some help here. I want to get monetized. Yes.
Let's go back to the other picture.
I may. I can, excuse me. Okay. So, okay, do you notice that adding and subtracting? I almost could have taught that in one lesson. I could have said, all right, here are the rules for adding, and then when we get to subtracting, what do I do with those subtraction problems? Make them into addition problems, right? And then follow those rules. You know what I could do with multiplying and dividing? I could teach it in one lesson. I could teach you rules today about multiplying and dividing, and then with, multiplying. And then with dividing, I could teach you how to turn them into multiplication problems. And then you could do that. Have you guys heard of inverse operations?
Yes.
What operation undoes addition? What undoes addition? Okay. What operation undoes division?
Multiplication.
Okay. Those pairs are very nice because you can undo each other. But there's a third set of inverse operations. I have two toes sticking up. Okay. We're going to talk about that toward the end. And it's one of those you're going to be like, what? How? Because we're not as comfortable. I know you know how to add. Yes, yes, you do know how to add. And I know you know how to divide, even though sometimes it can be tough. But these last two operations we'll talk about next week, they get tough. Okay, let's start looking at some problems, and let's see how this actually plays out. We're going to multiply 3 by negative 1.1. Okay, are these two numbers? Are there two factors, I should say? Two factors?
Yeah.
They're being what? Multiplied. So the rule is if two factors are being multiplied and they have the same, they have unlike signs, right? Positive, negative. What's the product going to be? Negative. Now I don't have to look at that negative positive sign anymore. I'm done with the signs. All I have to do now is multiply 3 and 1.1. So I'm going to put 1.1 on top. And just multiply it, I get 33 decimal point. So what's my final answer? Negative 3.3. That's it. That's all it is. Just got to remember the correct sign. Don't forget the sign. Does it matter with the sign?
Yes.
It does, right? It does. It does practically. It does in real world. And it does today on our assignment. Okay. Wow, that was it. Next one. I want you to do this one on your own. Negative 13.7 times negative 9.2. Don't tell me the answer, just work it out. First, sir?
Do you fold your nose too?
I do.
You fold
Whoa. I do. I fold my clothes.
everything. Most people do that.
Okay. I fold my wallet.
Most people do that.
I have a folding
You
wall.
fold your
Well, girls,
I do fold my collars.
We fold
Sometimes
our
they
collars.
pop it up. You know?
Your elbows are
Try to style it.
Oh, you Presley?
Yes, I fold a lot of
you
things.
fold your bed when you sleep.
Only when it's a sofa pull-out, you know, those
CG, I
pull-out
just said
beds,
that, so-
when I'm at a hotel or at a retreat coming up, maybe.
Yeah.
Yeah, I'm excited about the retreat, guys. I'm gonna have. I hope we can have fun.
Are we?
Swivl might be coming. No, he's not coming. He was totally scared last time. All the water, the dirt, the lack of electricity,
I don't
so
believe that.
he can't come.
I don't believe that.
Okay, go ahead and work this one out, guys. And I'm going to ask you a couple questions. The first question is the one you should be able to get right away. Obviously, 13.7 and 9.2 is not that easy to come up with in your head, but you do know the sign of the answer. It is, Danny, positive. It has to be a positive answer
Much positive.
because a negative times a negative equals a positive. Two numbers being multiplied with the same sign, positive, no matter what. Okay, now I have to do 13.7 times 9.2. Now, I want to remind you guys, when you're multiplying decimal numbers, do the decimal points have to align?
Yes.
No. When adding and subtracting, yes. When multiplying, no. But wait, these aligned. Fine. But they don't have to align. Like the last one did not align. All right, so we go 14, 7, 2, 0, 63, 27, 33, 12, 4, 10, minus 2, 1 decimal point. All right, guys, stay with me here. How many of you got 126.04? How many of you got negative 126.04? Good. How many of you got positive 126.04? Okay. You don't have to put the positive sign when your number is positive, but you can. You can do it or you don't have to, but negatives you must. Okay, that wasn't too bad. Let's go to the next one. Let's go with 6/7. You knew they were coming. And 4 1/3. Okay, I have two factors, guys. Two numbers being multiplied. Do you mind closing that door, Alex? Sorry, because I don't want the noise to carry through. I have two numbers being multiplied. They're both positive. My answer is going to be positive. Like, I hope that's pretty straightforward. Positive times a positive equals a positive. All right. But when I'm multiplying fractions and mixed numbers, you guys remember what I should do to make it easier? You don't have to, technically, but this is easier. Yes, Marshall? Yeah, so I'll change that to 13/3. I did 4 times 3 plus 1, and then over 3. And then, guys, how many of you aren't super big fans of reducing? Like, you wish you could just get that answer and be done with it, right? I'm not either. Sometimes I don't see what you can reduce by, or sometimes I know it's going to be, I gotta like divide by 8 or by 15 to make it reduced. Before you multiply, if you can cancel out any common factors, it will make your reducing eliminate from the problem. It's eliminated. Okay, so here, no, sorry, that's cross multiplying. This is canceling. Is there anything common between 6 and 7? Any common factor? 13 and 3? Is there anything between 6 and 3? Yeah, 3 goes into 3 once, 3 goes into 6 twice. Anything between 13 and 7? 13, 7, nope. Anything else left? Okay, now I'm going to multiplying. Guys, don't forget, when multiplying fractions, multiply numerators, multiply denominators. That's different from adding and subtracting. What's 2 times 13? 26. What's 7 times 1? Okay, so you don't have to reduce means you don't have to make these numbers smaller, but I do have to change it to what? A mixed number, which, how many times does 7 fit into 26? 3 times with a remainder of 5 sevenths. 3 and 5 sevenths positive. 3 and 5 sevenths positive. Ma'am?
This might be a dumb question.
No, sorry.
But how did you get 13/3?
Oh, 13/3 is I changed this mixed number into an improper fraction. So I did that times that plus that over 3. Yep, no, that's a good question. We need to clarify that. Okay, any questions on how to multiply fractions and or mixed numbers? All right, next. This one's all you then. 4/5 times negative 9/11. Give me the correct sign, give me the correct number, and reduce as much as possible. You may begin. So go ahead and write this problem, figure it out. Okay, I'm going to ask a random person, the person who's looking up will be called on. Morris, your answer is positive or negative?
Negative.
Negative. How many of you got a negative answer? Or at least knew it was going to be negative no matter what? All right, good. And then the numerical part, let's go with Ben. Okay, I'll give you some time. Once Ben gets it, he'll tell me. And then we'll confirm whether it's accurate or not. Okay, before I let Ben do it, is there anything I could have canceled out? Like anything I can cancel here, 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 here? No, nothing can cancel out.
Don't come to me. Don't come to me. No. Leave.
Swivl, come on.
Vacate peasant.
That's enough. Okay. So here, there's nothing to cancel, so I just multiply across. I get 36, and I get 55. And because there's nothing to cancel, I know that's simplified. But just don't forget, It's a negative 36/55. Negative 36/55. Yes. Yes, sir.
Do you have to be able to do the canceling thing?
You have to have common factors. Like, is there any number that divides into 4 and 5 evenly other than 1? Nope. 9 and 11? Nope. 9 and 5? Nope. 4 and 11? No. The last problem, we had, right, 6/7 and 13/3. Nothing canceled between those two or between those two, but look at 6 and 3. Doesn't 3 divide into both of these numbers evenly? It goes into this twice, it goes into that once. Then, once I've done all those cancelings, no more reducing. You're done reducing. And that happened on this problem. Was there anything I could cancel in the multiplication problem? No, so you just multiply across, that's my answer, and it's reduced. Okay, go on page 19 and do try these number 1 and number 2. And because I'm feeling so Friday-y, I'm going to have one person per problem work out the problem up here for us and get it correctly,
Wait, 19?
properly. Page 19, 19. Try these. Do number 1 and 2. On the bottom it says try these. Find the product. Work them out, and then I'll call on somebody for each problem. And you guys can do it at the same time because I could split this board in half and you could do 2 people at once. So. Okay, once I call on you, you're gonna show your work up here. I don't want just an answer. You're gonna work it up. CT, you could do this one right here.
Yay.
And Ryan, you could do the second one. Sorry, I didn't see the hand in time. But Ryan, you could do the second one, and you guys can start now. I have one marker. Excuse me, sorry. You can use that. And the other one's here. There you go. And why would they want to see me when they see you? Okay, so go ahead and work those out, guys. You're working both of them out on your paper. We're going to confirm things. Circle or box your answer, guys, up there so I know which one's what. And don't forget your signs.
Is that circle enough?
Yeah, I think so.
The shapes.
Okay, so on the first one, CT got negative. Is that proper? Is negative correct?
Yeah.
Yes. And then he got 37.71. Is that what you got? If it is what you got, that's good because it's correct. Negative 37.71. And then Ryan, yes, you did get a slightly tougher one because it says 3-digit times a 2-digit. But what did she get? Is it negative? Yes. Is it 12.36? Yes. So negative 12.36. Just stick it on that little spot on the bottom left. There you go. Awesome. Thank you, guys. That's it. That's what you do on that one. Okay. How many of you are good at mental math? Like you could do things in your head. Okay, Swivl, I have a confession to make, and I think I've already said it to you guys. Did I tell you how I do mental math, or like how well I do? Okay, let me tell you this. Ready, Swivl? And for all the people out there, I'm not very good at it. Not. When somebody gives me a problem, like 9 times 37, I had to sit there and think, all right, they said 37, and they said 9. And then I set up in my mind my folded paper, I write the digits, and then I start working out, wait, what was that number? 37 times 9? Okay, I struggle with it. So I want you guys to do 37 times 9 in your head. Go ahead. I'll put it up here, actually. Yeah, stay quiet so people can do it. So 37 times 9. So even that helps, just seeing the problem, but go ahead and do it. Don't give it to me. Yeah, I just want to give you time. And then in your notes, I want you to write this right here. We'll finish off with this property. I said, do not give the answer. Okay. Write that down, though, guys. Write that down. Okay. This is a property that is so important. I want to introduce it today. Your homework does not have this property on it. But I want to introduce it so you're exposed to it because this is going to be a useful property. And for now, then it's going to be vital later. That means you will have to use it in order to make things simple. All right, so what's the answer to 37 times 9? I forgot what it was. Yes, sir.
333.
333. Yes, 333. All right, how many of you got that? Okay, I'll be honest with you. I did this problem and I was like, in my head. And I was like, I just threw it up in my head. I think I switched it to 40 times 9. For some reason, I just said 40. Well, that's easy. Okay, so I messed up. But here, if you struggle like I do, we're going to find out a way to help us out to make these problems easier. And you've already used this method before. All right, here's what I want you to do. Write this down, guys. 9 times 37. Because we're gonna have to say, is what Mr. A is saying true or false? So we're gonna have to go through that process. Okay, this is the problem. Do you notice that I switched the order? That's a commutative property. I'm allowed to do that. You okay with that? Okay, good. Because people are like, wait, Mr. A, it's a different problem. It looks different, but it's the same answer. Okay, now write this down. Isn't 9 times 37 the same thing as 9 times 30 plus 7?
Yeah. No. Yes.
Okay, so listen to me. Is 37 30 plus 7? Okay, all right. You're like, why'd you do this? Well, I'll show you in just a minute. And I'm not expecting you guys to do this right away. It's the first time you've seen this, maybe. No, you've seen distributed property, but you may have not seen it like on this problem for whatever reason. All right. Now, instead of doing 9 times 37, trying to keep it all up there. Wait, what are the numbers? Okay. I'm going to do 9 times 30. So I'm going to write that down. 9 times 30. And then I'm going to add 9 times 7 to that product. 9 times 7. So you're like, wait, you made one multiplication problem into 2. Who would do that? Who would do such a thing? Well, what's 9 times 30? What's 9 times 3, by the way? With a 0 after it, right? So you know that. You should know 9 times 30, 27 with a 0. And then what's 9 times 7? 63, all right? And I said I was going to add those together. Does anyone know what 270 plus 63 is? 333. Oh, interesting. Now, it could be that it just happens to be the correct answer, right? Like we did this weird stuff to make it happen. You do this. How many of you would have done this problem I told you by paper like that? How many of you would have done it like that? Okay, great. You did this. You just did it differently. It looks differently because now it's vertical. This one's more, this one's like a certain way you've done it a long time. And then this is like, whoa, it's the same thing. Okay, but anyway, I'm not going to get into that detail. Do 18 times 9 in your head, please. In your head, just. Got it. Okay. Don't give it to me yet. Sorry. Let the people think.
Let the people think.
Yes. That's always a good thing. I like your thought. I could see your multiplication going on. You're telling me. You're kind of mouthing it. I'm like, okay, cool.
May I please?
Okay, don't give me the answer. Don't give me the answer. Save it. Maybe you could write the answer down if you, I will forget. Just whatever. Okay, ready? Is that allowed? Is that allowed?
Yeah.
Okay, now I'm going to show my work over here. Watch this, guys. Okay, ready? I'm going to say not 9 times 18, but 9 times 10 plus 8. Why would anyone do that? Because of this. Ready? Stay with me. Some of you are talking. You're not with me. 9 times 10 plus 9 times 8. All right, what's 9 times 10? What's 9 times 8? What's 90 plus 72? That's the answer.
I do it one at a time.
You do. You're right. Okay, next. I'm going to look at it in a different way, guys. This helps you to get number sense. You're like, wait, I guess that is true. Okay, do you agree that 10 plus 8 is 18?
Yeah.
Okay, ready? that allowed?
Yes.
Okay, ready? I'm going to do 9 times 20. So 9 times 20. And instead of adding, I'm going to subtract 9 times 2. What's 9 times 20? Put those away. What's 9 times 2? Some of you like subtraction. You said you liked subtraction yesterday. What's 180 minus 18? Huh, interesting. Same thing. Okay, do you have to see this number as only 18? No, you could see it as 10 plus 8 or 20 minus 2. You can see either way. Okay, I'm having a little bit of trouble over here, guys. I might have to move some seats because that happened yesterday too. You've seen this property mainly because I've asked Ms. Hill. Did you guys go over this property? Yes, you did. But we're going to see why we use it more and more as the year goes on. Okay? All right. That's it. Homework. 2 through 30 even. There's 2 through 30 even. And that's on page 17. Yes, you may. Let me pause. So bye-bye.